This is the nerve center for Prosthesis, the anti-robot, and I'm Jonathan Tippet, the creator and leader of the project. I've brought together an amazing team of my friends, people who have been watching the project unfold for years now. This is the nerve center. This is where the sort of design control happens and where all of the manufacturing drawings are produced. Over here we have the hydraulics R&D center. There's a couple of students from the UBC engineering team who are doing the hydraulic system for Project Alpha, which is a 2/3 scale single leg of the entire machine. And the hydraulics team is responsible for kind of putting the muscle into the machine. And we have resurrected the Mondo Spider motor. The Mondo Spider was basically seeded by this motor. Dillard Brinson back in 2005 bought this lovely $5,000 piece of Honda equipment to power the Spider back in the day. And the Spider has since evolved into a full zero emissions electric machine. Again, of course here at Eat Art we try to avoid conventional internal combustion power sources because we're trying to develop and promote new and alternative energy and focus on efficiencies. But as is the case with most technological evolution, you have to start with what you know and what works best, which right now is internal combustion, gasoline. This 25 horsepower engine will just barely operate one 2/3 scale leg. And so I've agreed to, for the purposes of our engineering students who are developing the suspension and the hydraulics, to build a leg for them to put their stuff on. This is where I pin up all of the things that need to be made. It's really challenging sometimes to manage the amazing team of sort of 5 to 12 people who show up on a given work session. So I've developed a system where I just put up drawings, and if someone comes in and says, what do we need to make? I point them at the fabrication board, and they have all become pretty much self-sufficient, autonomous fabricating machines. And they just grab something off, they read the part designation, and they find the material and make it. And the process that we've had to resort to is the good old traditional wrap and grind template method, where we print up a template on paper, which we've generated using CAD software to sort of develop the profile of the tubes. And there's some fantastically complex and challenging cuts that can be achieved with a very low level of effort and skill. So you can hand anyone who's just learning how to do metalwork a template and a piece of material, and they can produce a really accurate part. And this is how we built the Mondo Spider. You are here. How's this looking? It's looking great. You gonna nail it?
I have to.
So Anton's building a jig which will be used to hold all of the parts in mid-air while we weld them into place. So when he finishes this jig, we put the bearing mounts and all the sort of critical nodes of the structure on the jig, and they kind of float in the right position, and then we basically connect the dots with all of these carefully cut tubes that people have been churning out for weeks. And the end product is a structure like this, which is barely even liftable. This is the present pride and joy of Project Alpha. This is the thigh, or the upper leg. It will bear the vast majority of the loads for this whole project. This is a 2/3 scale unit, don't forget. The real one will be this tall, and hopefully not much heavier. This unit was overbuilt out of mild steel because it's easy to work with and it's inexpensive, and we kind of had to train up the team on their TIG welding and their fabrication skills, so best to do it on something that's abundant and relatively less expensive. This guy, weighing in at 45 kilograms, will be suspended 2 meters in the air on top of this tower, which I'm a huge fan of because it has a built-in ladder. The notion of having a moving part with a ladder on it, because it's so large, really kind of amuses me. So you'll climb up the ladder, much safer when there's something holding the ladder up, to the top where there'll be a platform, probably another meter up there. And that's where the operator ultimately will sit. At this bearing here, we'll pivot the thigh, the upper leg that I was just showing you. So that will be hanging down here with the rest of the leg components on it. And then this whole thing will move back and forth. The roar of the old spider engine powering the whole process. Whew. And that's how we're going to test the system.